During the brutal Atlantic winters of World War II, survival wasn't just about endurance. It was about innovation. When Allied sailors were cast adrift after their ships were torpedoed, their lives depended entirely on what they carried in their lifeboats. There was no wood to burn, no open flame to cook with, and no shelter from the freezing winds. Yet somehow, these men found a way to heat food and melt ice into drinkable water without a single visible flame. The secret lay inside a small, unassuming metal canister, the lifeboat stove. At first glance, it looked ordinary, but inside that tin was one of the most ingenious survival tools ever made. A stove that burned without flame, without smoke, and without revealing a ship's position to the enemy. It was born not from luxury, but from desperation. When the war broke out, naval engineers faced a chilling truth. Sailors were surviving shipwrecks. Only 2 days later, from exposure in the icy Atlantic. They needed a heat source that was compact, safe in confined spaces, used little oxygen, and didn't betray their location to patrolling submarines. What they created was nothing short of brilliant, a chemical miracle known as a cold fire. The stove used a solidified form of alcohol, a jelly-like substance made by mixing ethanol with a compound called calcium acetate. That simple reaction turned liquid fuel into a stable gel that burned cleanly and steadily. When ignited, it gave off no visible flame, only a faint blue shimmer that could barely be seen, even in complete darkness. It radiated warmth quietly, producing no smoke, no flicker, and no glow that could reveal a stranded lifeboat to the enemy. Compact, reliable, and long-lasting. A single canister could heat a meal or melt ice into drinking water for hours. The genius was in the chemistry. When the gel was lit, the ethanol vaporized and oxidized. But because the calcium acetate limited oxygen flow and stabilized the burn, it produced heat without visible combustion. The energy released was transferred through radiant warmth, not light. That meant sailors could safely use the stove even beneath a lifeboat canopy, without risking suffocation or detection. Unlike kerosene or solid fuel tablets, which flared up dangerously, the gel burned evenly and predictably. A sailor could hold his hands above it and feel the comfort of heat without the threat of flame. In the biting cold of the North Atlantic, that steady warmth often made the difference between life and death. But the story didn't end there. After the war, the lifeboat stoves, designed quietly, influenced an entire generation of survival technology. Its principles appeared in post-war survival kits, Arctic expedition gear, and even Cold War emergency rations. Tiny metal tins labeled flameless solid fuel or self-heating ration heaters were direct descendants of this wartime innovation. Even NASA's early spacecraft carried chemical heaters based on the same science. Contained systems that produced heat without flame. Soldiers in Korea and Vietnam carried similar heat tabs, compact, flame-free gels that could warm food discreetly in the field. The concept remained the same: clean, efficient, and nearly invisible heat. For modern survivalists, campers, or preppers, the idea still holds value. There are moments in tents, snow caves, or stealth camps where open fire simply isn't an option. Understanding this wartime invention can mean the difference between risk and resilience, and the principle can be recreated safely today. By mixing denatured alcohol with a small amount of calcium acetate, about 1 teaspoon for every 100 milliliters of alcohol, you can form your own simple gel fuel. Stir slowly until the mixture thickens, then store it in a heat-proof tin. When ignited, it burns steadily for 15 to 20 minutes, long enough to warm soup, boil water, or brew tea, all with minimal light and almost no smoke. It's simple, efficient, and remarkably effective. But always test it outdoors first, and use proper heat-proof containers with good ventilation. While modern fuel tablets and portable stoves have evolved, none quite capture the understated brilliance of that forgotten wartime design, because the lifeboat stove was just a toolet. It was a symbol of problem-solving under pressure, a quiet triumph of chemistry over chaos. The engineers who designed it weren't just building heat, they were building hope. They understood that a small, safe source of warmth could mean the difference between despair and endurance. Today, in an age of high-tech survival gear and tactical gadgets, The lifeboat stove reminds us that the smartest solutions are often the simplest and the quietest. It has a lesson from the past that still burns true today. That survival isn't about noise, it's about knowledge. Every time you strike a match or light a stove, you're connected to those inventors who faced the cold and found a way through it. The lifeboat stove, though nearly forgotten, deserves a place among the world's great survival innovations. Because by studying it, we don't just honor history, we learn how to endure. In a world where power outages, climate events, and isolation grow more common, knowing how to create clean, safe heat without fire isn't just fascinating, it's practical. It's the kind of knowledge that could once again save lives. So keep that spark of curiosity alive. If this glimpse into wartime ingenuity stirred something in you, if it reminded you how creativity burns brightest in the darkest moments, don't let it end here. Explore more. Experiment safely. Share what you learn. And keep this piece of forgotten survival history alive by subscribing to In the Beginning. Because the best lessons for the future often hide inside the quiet inventions of the past, and it's up to us to keep them burning.